Hi, I'm Zoe Ma, and today I'm here to talk about how to create a churn prediction model with Amazon SageMaker. Amazon SageMaker helps data scientists and developers to prepare, build, train, and deploy machine learning models quickly by bringing together a broad set of capabilities purpose-built for machine learning. In this video, we're going to show you how to use various SageMaker functionalities to build, train, and deploy a churn prediction model from end to end, including data pre-processing steps like ingestion, cleaning and processing, feature engineering, training, hyperparameter tuning, evaluating your model, and eventually deploy it to make predictions. We will perform these steps from SageMaker Studio, which is a web-based visual interface that gives you complete access, control, and visibility into each machine learning development step, all in one place. For how to set up SageMaker Studio Notebook environment, please check the onboarding video linked in the notebook. So for this use case, there are two parts of the demo. In part 1, prepare data, you will process the data with the help of Data Wrangler, then create features from the cleaned data. By the end of part 1, you will have a complete feature dataset that contains all the attributes built for each user, and it is ready for modeling. Then in part 2, modeling and reference, you will use the dataset built from part 1 to find an optimal model from the use case, then check the model prediction results with the test set. To start with part 2, you can either read in data from the output of your part 1 results, or use the provided full feature dataset.csv under data folder as the input for the next steps. In order to follow along this demo, you will need to clone the example repo and download the datasets. Once you are in the SageMaker Studio console, you can go ahead, click on the Git tab, and click on the Clone a repository. I already have the repository cloned here. The repository contains the example notebooks, datasets, a sample data flow for the Data Wrangler, and also a Python file that contains the code for the SageMaker processing. In the data folder, you will find the full raw dataset in zips files, simulation 1 through 4, and a smaller size sample data for you to explore. 2 processed datasets are also provided, including a full feature dataset, which includes all the user-level features we created from the raw data, and it is also the output from the part 1 prepared data, and also the splitted train, validation, and test data that are ready for modeling. You can look at the first dataset to see the results of the part 1 data processing and feature engineering, and use the second dataset to experiment with modeling and hyperparameter tuning without running the whole notebook. Now, let's go back and open this notebook. I already have it open here. In this example notebook, we have a mix of documentation and code in Python. We will work through a pre-run version of this notebook so that we can see all of the outputs at once. For this use case demo, you will utilize the following SageMaker capabilities to simplify and speed your machine learning development. For data cleaning and pre-processing, you will use SageMaker Data Wrangler, a feature that allows you to import, normalize, transform, combine data sources, and also create features without having to write any code, while managing all of the processing infrastructure under the hood. For feature engineering, you will use SageMaker Processing, a capability that lets you easily run your pre-processing, post-processing, and even model evaluation workloads on fully managed infrastructure. You can also use SageMaker Data Wrangler for feature engineering steps. But for this use case, we decided to go with SageMaker Processing because our data is very raw and some intensive feature creation heavy lifting is needed, including aggregation from event level to user level, calculation of user listening behavior metrics, and also a few functions used to add time factor to the user behavior metrics, such as advertisement listened by the user in 30 days, 60 days, and also 180 days. Next, for model training, you will use a SageMaker building algorithm called XGBoost to predict if a customer is likely to churn. SageMaker building algorithms provide highly optimized implementation of popular machine learning algorithms simplifying the machine learning development and also accelerating your training and development. For training and hyperparameter tuning, you will use the SageMaker Hyperparameter Tuning job. It is a SageMaker feature that automates the hyperparameter tuning process and also eliminates the undifferentiated heavy lifting of searching through numerous combinations of hyperparameters. It launches multiple training jobs with different hyperparameter combinations, then trains a meta machine learning model based on Bayesian optimization to find the best model. You can create a tuner job, use the SageMaker console, the low-level SageMaker API, or the SageMaker Python SDK. For deploying the model, you will use the SageMaker Batch Transform, a SageMaker feature to transform data and also generates inferences. It is ideal for scenarios where you're dealing with large batches of data, don't need sub-second latency, or just need for both pre-process and also transform the training data. You can create a batch transform job from the SageMaker console using the SageMaker high-level Python library or the SageMaker SDK. Lastly, for model explainability, you will use the SageMaker Clarify, a new SageMaker feature that provides bias detection across the machine learning workflow and also feature importance for your model. In this use case, you will use it to tell how each different feature inputted into the model is affecting predictions. So let's dive into this churn use case. What is customer churn and why is it important for business? Customer churn or customer attrition means that a customer has the tendency to leave and also stop paying for a business. It is one of the primary metrics companies use as a health indicator for the business and also get a sense of their customer satisfaction. Some use cases for customer churn includes music and video streaming services, software as service providers, and also telecom companies. Then, how do we formulate a machine learning problem for churn prediction? You can start with the most straightforward way and predict whether a user will cancel, or if you want to detect early signs of leaving, you can predict whether a user will downgrade a pricing plan or renew a subscription. You can either formulate it as a classification problem as above, or a time series to predict when will a user churn. To collect data for churn prediction, some most common data sources are customer relationship management platform, like a CRM, engagement and usage data. This is usually event level log data, so you might want to aggregate data to a certain level to use it, and this is also the same case with the dataset we're using in this demo. Feedback data, and that includes customer support requests, feedback on social media, or in App Store. These are sometimes text data, so some level of natural language processing is needed. Some challenges with customer churn include imbalanced class, where fewer churn data is available, which we will discuss for this use case example. Another one is user identification mapping problem, which means that if you're joining data from different platforms, you would want to make sure that user A is always identified as the same user across multiple platforms. Now, let's start our use case walkthrough. For this use case, we are going to use the simulated music streaming event level usage data and transform the dataset into a feature dataset that we can use to predict if a customer will cancel the subscription. This dataset contains about 1,100 users and their user behavior for about 1 year. Each row in the dataset contains one event and has information about the timestamp of the event, user, page name, some demographic information, some attributes, and also session information. An architecture diagram is also included here to give you a sense of the flow for this demo. We're going to ingest the data from S3 bucket into Notebook for exploration, then using Data Wrangler to do pre-processing. The data from Data Wrangler will be ingested into processing for feature engineering, and then we're going to ingest the feature set to the XGBoost model for modeling, and we will use Hyperparameter tuning job to find the optimal model. And eventually we will use the batch transform to inference the output and find the prediction results. All the results will be saved in an Amazon S3 bucket. We'll also use Amazon SageMaker Clarify to find out which features are most influential to the model prediction results. Now let's start our part 1, prepare data. We'll first need to set up the notebook. Pretty standard process for a lot of studio notebook. And set up parameters, which we're going to use in this notebook, and that including a bucket name, a prefix, region, row you used for execute a lot of commands in this notebook, and also a SageMaker client. We're going to download the data from GitHub and also upload them to Amazon S3. Then we will start the data cleaning and data exploration. By the first look at the data, we are going to remove some irrelevant columns first. And that includes methods and also status. Next, we will look at null values for each column, and we're going to remove all events without an user ID assigned, since that's how we will identify a user for our use case. In this case, about 3% of users do not have a registration time, so we will remove all those anonymous users from the record as well. Now, let's take a closer look at the data. Here, we're listing unique values or number of unique values for each categorical column. And some key observations from the data are: first, the location and user agent are not great categorical features as they contain too many unique values. And when you use one-hot encoding to convert all those two features, they're going to become too many columns and bring little value to your model. So we're going to remove them. Artists and songs, those can be quantified to a user level. That means features like how many songs that the user has listened to or how many artists the user is following. For the column page, cancellation confirmation can be used to label user churn. And other information is pretty valuable as well, like downgrade, upgrade. This can all be quantified and aggregated to the user level as well. We can also extract date features from the timestamp so that we can build some timely features. One thing that is kind of worth noting is that the imbalanced class. It can be misleading for some machine learning models as the accuracy will be biased towards the majority class. And in this case, you have about 12% to 13% churn users, so you can either sample your data or choose an algorithm that is less sensitive to imbalanced class and choose appropriate evaluation metrics, which is what we will do in this use case. To summarize every pre-processing steps you have covered, we have done null removals, dropped irrelevant columns, convert event timestamps to features, and we also create labels. Now that you've finished cleaning and processing the data, let's start exploring the data a little bit furthermore so that we can decide which features to create in a feature engineering. Some possible directions to explore are listed here, and we're going to explore 3 of them. We will start with activity time. The following 2 plots are generated with the code and under Python library, matplotlib, and Seaborn. The first plot shows that the distribution of the average number of events per user per day in breaking down by churn users and active users, and also by weekends and weekdays. You can see that churn users are more active on weekdays than weekends, whereas active users do not show a strong difference between the two. That means average events per day on weekends and also average events per day on weekdays can be 2 useful features here. The second plot, however, does not really show significant differences between day and night for both sets of users. so we will skip it as a feature. You can also look at some basic statistics for users' listening habits. We are looking at average total, that includes number of sessions, app usage length, number of songs listened, number of artists listened per user, number of advertisement days active, and we're also going to look at the same metrics on a daily level. In this case, churn users are actually heavier users. From the two sets of data we can look at, they listen to a wider variety of songs and also artists and spending more time on the app. You can further explore how the users are using the app besides just listening by looking at the number of likes and dislikes, number of songs added to a playlist, advertisement, adding friends, if a user has downgraded or upgraded their plan, and how many errors the user has encountered. Churned users are slightly more active than all the other users from our data. And that means that they encountered more errors, listening to more advertisement, and had more downgrades and upgrades. These statistics can be built as numerical features such as number of total events per type per user, or more advanced time series numerical features such as errors in the last 7 days. Now that you have a good understanding of your data and decide which steps are needed for process your data, you can utilize the new Amazon SageMaker Data Wrangler feature to prepare your data for machine learning. You can open a new launcher, and from the launcher, you can click on New Data Flow to start to create your Data Wrangler job. You can choose to select data from Amazon S3, Amazon Athena, Redshift, Lake Formation, and Amazon SageMaker Feature Store. I have already uploaded the CSV version of the full dataset into S3, so we're going to import a full dataset from the S3 location. Choose Amazon S3, choose our default SageMaker bucket, and under Music Streaming, and Data, CSV, we have the full dataset. Click on Import Dataset. Now that you have completed the first step in the data flow, you can proceed to transform and add transformations by click on the plus sign and add transformation. With over 300 built-in data transformations, you can transform data including handling missing values, outliers, managing columns, and even adding custom data transformations. I already created a list of transformations here in my flow file, and that including removes a few columns, managing columns, handling missing values, and change the format of the data. When we're done with the data transformations, we would like to save the output data somewhere for easy access. So by choosing export, and by choosing all these steps you want to export, by clicking on export steps, and by choosing Data Wrangler job, SageMaker Data Wrangler will create a notebook for you. And by running this notebook, it creates a job and also creates the output in an S3 bucket. Because Data Wrangler integrated nicely with all the other SageMaker services, in the export, you can also export it as a pipeline or to feature store, which is another new SageMaker feature that allows you better manage your model features. Remember to save this output path so that you can read the output in the churn prediction use case notebook. So we will run through this notebook and go back to our use case. Now that your data is prepared using SageMaker Data Wrangler, it is ready for feature engineering, and we're going to use SageMaker processing to speed up the process. Since the dataset is time series, you can enrich your features by adding a time factor to it. For example, for the total number of songs listened, you can create features like total songs listened by the user in the last 7 days, 30 days, 90 days, 180 days, and so on, to see how active this user has been in the timeline. The features built for this use case will be at the user level, where each row represents one user and will include the following features. The average number of events per day during the weekend and during the weekday, number of advertisements and total errors encountered in the last 7 days, total songs played in the last 7 days, 30 days and 90 days, number of artists and songs played, number of advertisements played, encountered error, number of times the user likes and dislikes a song, add the song to a playlist, and as a friend. User has downgraded or upgraded plan. Percentage of users' action is next song or row advert, which means advertisement. Percentage of total songs that are repeats, meaning that if the user is a repeat listener. Days since the user being active. Number of total sessions, and also average time spent and average time number of events per session, and also average time between each session. So between 2 sessions, how long it takes for the user to return to the app. So the following function will create and also run your sklearn job using the SageMaker processing SDK. Your pre-processing script will be run like the following steps. The dataset is automatically copied inside of the container under the destination directory, which in this case is under the /input. This is where the Python script reads it, which is the preprocessing.py. Optionally, we could also pass command line arguments to the script. Here, since the job will take the output from the SageMaker data wrangler job above as the input, you will save the data wrangler output name and pass it as an argument to the SageMaker processing job. It processes it and saves the file inside the container under the opt.ml processing/output. Once the job completes, all the output are automatically copied to your default SageMaker bucket in S3. This is the processing.py file, and it includes a lot of feature creation steps we just mentioned in the exploration steps. We're creating a bunch of features, and finally we're combining all the features together. We're renaming some of the columns, and eventually we're only keeping the created features columns. Then after this function starts to run, it will take about 5 minutes. Once it finishes, you can find the output processing_job_output CSV in the SageMaker processing job folder in your default S3 bucket. Great, congratulations, you have completed the part 1, prepare the data, and now you should have created the complete feature set that is ready for modeling. You can now proceed to part 2, modeling and reference. Now that you have created the complete feature set, you can start to explore and find the best working model for your churn use case. By the end of part 2, you should have selected an algorithm, find the best sets of hyperparameters for the model, examine how well the model performs, and finally find the top influential features as an action item. To start with part 2, you can either read in data from the output of your part 1 results, which is the processing_job_output.csv, or use the provided data/full_feature_data.csv as the input, which is the variable data frame processed data for the next step, which is also the last step before feeding data into the model, and that is splitting data into train, validation, and test. Here, we are splitting data in a way that data of both classes exist in all 3 datasets and making sure that both classes are represented in all datasets. All the split datasets are also provided in the GitHub repo, which we just mentioned, the trained updated CSV, validation updated CSV, and also test updated CSV. so you can also use them as input to experiment with your own models. Now, here comes the exciting part. Our data is finally ready to be trained. Before choosing an algorithm, you should always start with a simple one. Think about data structure and interpretability. You would also want to utilize the SageMaker building algorithms to simplify and accelerate your training process. For a complete list of available SageMaker building algorithms, you can always access examples, notebooks, and documentations from the SageMaker Jumpstart page. By opening a new launcher, clicking on the plus sign, click on Jumpstart. It will bring you to the Jumpstart page, where you can find some solutions for different use cases, and you can find text models, computer vision models, and finally SageMaker algorithms. You can click on any algorithms that you're interested in. Then it will bring you to this example notebook showcasing how the algorithm works. Now, let's go back to our use case. In this use case, we will go with a tree-based model XGBoost due to the consideration of imbalanced class. And in the family of tree-based models, XGBoost usually provides the best results as it is built and optimized for performances and speed. It is also one of the SageMaker built-in algorithms, so we're just going to utilize it in this use case. To configure a training job, you will need to choose evaluation metrics and also hyperparameters. Here, you can initialize the training job from the notebook using the SageMaker Python SDK, and you can do the same thing from the console. From an imbalanced classification problem, you can choose F1 score as your evaluation, especially for comparing different models. Area under curve, which is AUC, is also a good choice when your model output is probability. You can also define a job as a trial with SageMaker's experiments, and you can easily check for analytics. Same as training job, you can create a trial and experiment from the Studio Notebook using Python SDK like what we just did, or you can just create an experiment from the SageMaker Studio GUI tool by choosing the components. Then choose experiment and trials. Then click on experiment. By clicking on this create experiment, it will bring you to this page where you just need to configure a few things. And you can create the experiment from here without writing a code. In this use case, we will drop this Python SDK and we will show you later how to do it. Here, to create a training job, we will first need to get the ECR image for pre-built SageMaker Docker images. Once you have that, we will initialize the model hyperparameters with a bunch of default values. We choose the AUC as the evaluation metrics here. And we will define the SageMaker estimator with all the hyperparameters we just defined and also the input path. After we import all the training input into our estimator, it will start to fitting. And eventually you can define a SageMaker experiment and trial by using the SageMaker Python SDK. This is what the analytics table will look like. If you have multiple models, you can easily compare different evaluation metrics value here and simply choose the best one. Great! Now that you understand how training one model works and how to create a SageMaker experiment, and also you selected the XGBoost model as the final model, you will need to fine-tune the hyperparameters for the best model performances. For the XGBoost model, when we're specifying the hyperparameter tuning ranges, in the config file, we can start with the ETA, alpha, mean child weight, and max depth. There are a bunch of more other parameters you can tune, and you can look at the hyperparameter tuning job documentations for more information. Here, for this strategy, you can either choose a random search where Hyperparameter tuning job choose a random combination of values from within the ranges that you specify. Or you can choose Bayesian search, where it kind of treats the Hyperparameter tuning like a regression problem, where it optimizes a model for the metric that you choose. To solve for a regression problem, Hyperparameter tuning makes guesses about which hyperparameter combinations are likely to get the best results, and runs training job to test those values. Here, we can go with Bayesian search. You will also need to configure the training job that the tuning job launches. And by defining this JSON object, you're essentially defining input and output path, format, and finally, we're launching the job. We're launching this Hyperparameter tuning job by using the Python SDK, but you can also create a Hyperparameter tuning job from the SageMaker console. Once the job launches, you can always monitor the progress of the Hyperparameter tuning job from the console as well. By going to the console and already choose my Hyperparameter tuning job, under training jobs, you can always look for how many jobs are completed, how many are in progress and stopped and failed, and you can check for the metrics value for each job and comparing them. Once the job is finished, under the best training job, you can find your best job and even directly create a model from here. Now, let's go back to our notebook. The training job itself will take about 20 minutes. After it's done, you can check the best model and deploy it with batch transform. You can deploy the model directly from your Hyperparameter tuning job. And once deployed, you will kick off the batch transform job here with the SageMaker Python SDK. Once the job is finished, we will deploy the best model from our training job. And also tell the batch transform job where our test data is, which in this case is test.csv. And then we will call the transformer, which is the batch transform SageMaker Python SDK. And it's running. Once done, you can download the model results to your instance for further analysis. Let's compare our model results to actual with the test set we left out earlier. We're going to look at the F1 score, precision, and recall. In churn analysis, precision means that of the user predicted to be churned, how many actually churned. And recall means that what percentage of churned users the model successfully find. From the results, we can see that the best model has a good F1 score, and it can also detect about 77% of the churned users before they leave. Lastly, you can visualize feature importance with the new SageMaker capability, SageMaker Clarify, which provides greater visibility into your training data and models so that you can identify and limit bias and explain predictions. It will provide sharp values, which will help you visualize feature importance. For all the other Clarify capabilities, you can check the documentation linked in the notebook. Here, we're utilizing the SageMaker Python SDK for Clarify again to initialize a Clarify processor job. We're defining the training input, our model endpoint, defining the shape config, data config, model config, so all the configuration files we needed for the Clarify job. And eventually, we're kicking off the job by run explainability from calling the Clarify processor. The job will give you a bunch of values after it's done, including all the shape values for each feature. You can check the values here, or you can visualize all these features by going back to the experiment. Under experiment and trials, so this is what you will see when you open the experiment and trials, and usually it's under the unassigned trial components. Double click, and you can always search for the child component name, and it will start with clarify. So we can choose the most recent SageMaker Clarify explainability job here. And just by looking at the feature importance plot, we can see that days since the user has been active is a strong indicator, which makes sense since from the data exploration, we know that churned users are actually more active than those who did not churn. Dislikes and numbers of errors and advertisement also plays a factor in the model prediction. These feature importance results can be insightful when you think about the action items or what do I do with this model after you deploy it. For example, the next time a user downgrades a pricing plan or has not been on the app for a given period of time, perhaps the logical step will be providing promotions to retain the user. Great, now let's go back to our use case demo. You have successfully built, trained, fine-tuned, and deployed a model to predict whether a user is likely to churn for a music streaming company. You can further explore other options SageMaker provided, such as SageMaker Autopilot, which can help automatically build, train, and tune the best machine learning models based on your data, while allowing you to maintain full control and visibility. This is the end of the demo. Here are some example code to show you where to find AutoML and how to deploy the model. Thanks for checking out this video. I hope this is helpful. If you're interested in other use cases as well, you can check other demos provided by Amazon SageMaker.